Good evening, everyone. I am Sari, program coordinator of Business Services Israel. It's a pleasure to welcome you all to the final session of the program on low voltage electrical distribution systems in buildings. Over the past weeks, we have had a very comprehensive learning. We begin with the fundamental low voltage distribution, switch gear and production, silent, integrated and design prevention of cables, buckways, and fire circuits detection. We will explore power quality and power factor reduction, focusing on how enhance system efficiency. Moving forward, we dive into transformer and leakage detection and signal diagnosis, visualize and coordinate systems. Finally, we did few daily systems, step-by-step we study with real work case studies. Today's session is designed to bring all steps together. The objective of this practice is to discuss critical ideas based on advocates, share industry experiences, listen, learn, and practice.
It's can't hear.
Sorry, I think you better switch off your video and then you can do the interaction. Yes. Tasan, you can continue. I think hope that you switch off your video and you can.
Share industry experiences, lessons learned and best practices, and explore how modern technologies
Sarani,
automation.
sorry to disturb you now. There are some echo. I think can you mute your another device here? Maybe there are some echo.
Explore how modern technologies, automation, and smart controls can further enhance system efficiency. Now, it's my privilege to introduce our distinguished panelist, Engineer Kaushalya Alpitarachi, a highly respected senior consultant and chartered electrical engineer with extensive expertise in low voltage systems design and building services engineering. He also CEO Amity Power Consultants Private Limited. Engineer Kujana Veerasinghe. He is a highly qualified consultant specializing in building services, chartered electrical engineer with strong expertise in electrical installation and telecommunication systems. He is founder of Rico Engineering Consultants Private Limited. He also council member of Building Services Industrial Campus. Engineer Dhanushka Ratnasurya. Experienced professional in electrical engineering with strong expertise in sustainable energy and building services, an active member of Lanka Association of Building Services Engineers, member of IET UK, and the director of DMEP Group. He is also council member of our campus. We are also pleased to have Engineer Lakman Isuru, CEO, Building Services Industrial Campus, as our moderator. With that, I encourage all participants to actively engage, ask questions, and make the most of this final session. Thank you all, and let us begin the session. Over to you, Engineer Lakman Isuru, moderator of the session.
Yeah. Hope all audible me. And thank you very much, Tassarani. She's a program coordinator of Building Service Industrial Campus, who introduced for the panel members and myself for the discussions. And first of all, I must apologize from the participants for the disturbance happened due to the network issue. So that unexpected consequences can be happened at any event and such like that. Anyway, this is live program. So you are on YouTube and Facebook now. This is on air at the moment. While we are delivering this session in the Zoom for the our CPD student, right? And also, from my end, as a CEO of the Building Service Industry Campus, I warmly welcome for the distinguished panel members for the sessions. So, and initially, I must thank to all of you to allocate your time, to reserve your time for this important session. So, because you know the value of this kind of session for this field. Yes, without taking much time, I'd start in the session. Actually, now these sessions come at the our CPD, which is the low voltage distribution system design, which has been conducted by engineer Kaushalya. So I know this course, CPD course, is being done by the BSIC. Today the 8th day that we have conducted in for the 7th day. It was really interesting, and we had a more positive comment from the students who are participating in this course. And also so we had a plan to have the online panel discussion for these, and also it will be delivered to the all over the world via YouTube and Facebook online platform to share our knowledge and views for everyone. Now, so I am the moderator of this session. So I will be calling for a questions from the panel members, distinguished panel members. This on behalf of the participant and the students. Also, those who are joining in the Zoom, they are the paid student. They have their own privilege. So you can raise at any time that any question related to the subject, as well as anything you want to experience with and you want to share with the audience and the panel members, your experience as well. You can share with these distinguished panel members as well as all the viewers who are joining with us. Okay, without taking much time, so as an initial step, I would like to call panel members for the discussion. My first questions to Engineer Kujana. Engineer Kujana is he know about these CPD courses because he has been engaging with the CPD course module moderating part for long period in this field. So Engineer Kujana, so in your view, so how do you think about and what is your feedback of this course? Actually, now we have been conducting this course for the 8 weeks. Today is the last day. And how do you think about the importance of this low voltage distribution course for the industry?
It's good evening, Engineer Isru. Am I audible?
Yes, you are audible, Kujana.
Okay, thank you. Good evening, other resource person and all the participants. First of all, I would say that not only this particular CPD, there are several CPDs that have been done by BSIC. Then when we consider this particular CPD for buildings, we know that there are a lot of services in the building when we are designing the building. Out of that, electrical LV system is the very important part, because as far as safety, electrical safety is concerned, then we realized that the particular LV distribution system in the building, that course content and what are the practical things need to be discussed, because the thing is, you know that undergraduates, they are passing out from the universities, and all other state and private universities and other institutes, they have normally they come across with a lot of theories and LV systems theories normally they have done. But the thing is, when they come to the designing of particular systems, we know that lack of knowledge or how to use this particular their knowledge to as a practically do this particular building designs for electrical systems. We have identified that gap. Actually, Engineer Suru and BSIC, the team members, they need to fill this gap, and they need to prepare, they need to build a bridge to complete this particular gap. Then we decide to prepare this course. Fortunately, we found very experienced senior consultant, engineer Kaushalya, and engineer Kaushalya prepared this particular uh, course and contents with his experience. I think we did a very successful course. Basically, those are the feedbacks. I think we did, as far as I'm concerned, we covered a lot of part. Then who covered this particular course, I think now they enable to do their own design with this course content. So, Engineer Suru, thank you.
Yeah, I think, thank you, Pujana. Actually, I think you know the importance, and you have given the
Yes.
right answer for the questions actually. So actually, because you are the one who involved to compose this kind of the courses to the BSIC as the council member of the BSIC, and also we know how, and also the input, the how our lecturer, the engineer Kaushalya, dedicated his time and his knowledge and experience to the courses. Yeah, thank you, Pujana. So I would like to bring engineer Kaushalya for the discussion. Yeah, engineer Kaushal. Yeah. Now, actually, you have been conducting this course for 7 days, and today is the last day. So you did wonderful jobs to the industry through this course. I know then your experience and your knowledge. And now, in your course, actually, you have given the good sound technical background for the student and the participants. So, what do you think now? Actually, now the electrical is a vast subject. Now you link this LV theories for our building services. Now single line diagrams for the electrical design is maybe the key as far as I know. So when you developing the SLD for the step by step to the calculation and the line diagrams. So in your teaching experience, so what is the common calculation error that maybe the first engineers or whoever engineers who can do, especially for the cable sizing, the breaker sizing, and the things? Then what do you identify the common error for this?
Right. Good evening, everyone, and thank you very much for inviting me to conduct this lecture series. First of all, to BSIC team And thank you all the participants for participating for the series. So if you come to the question, yes, first thing, what I say is the lack of core understanding the core of the subject. First thing, and practice. Because if you want to do a design or whatever it is, so you should have a good practice and the mentorship. Thirdly, you should be mentored by a good sound person with good and sound knowledge. And thereafter, adhering to those standards. So I am generally not a fan of following thumb rules. So I don't encourage that, because thumb rules don't always satisfy the requirement.
Yeah.
Right? If you take a cable calculation, there are thumb rules like for 30 ampere circuit breaker, 6 millimeter squared cable, 40 ampere 10, 63 16. This is not always correct. So if it is a PVC 4 core, 16 may not go with the 63 ampere circuit breaker. Likewise, that there are so many factors that is defined there. That is why following the right methodology is important. So that mentorship should be there. That is why we are discussing all of these. So if you go into a step-by-step approach, you are almost there. Maybe you have to do hundreds of thousands of designs to learn this, how to do it correct, in a correct way. So in every failure, you are learning something. That learning phase is very important. You can make mistakes, right? But you can't publish it with mistakes, because the whole community is going to suffer. So before you undertake the responsibility, you have to make sure that it is correct. That is where this mentorship comes into the picture. So your mentorship should be very strong and should be sound. Following the right standard and identifying right need will ensure your best results in your design. So apart from that, the updation, you need to update, because all these standards update regularly. So that updateness in you is very important. So you have to update day by day. And I discussed few factors if you are a designer to do. First thing, you need to look, right? You need to look at the things, not just to see. You need to learn how to sharpen your senses. Then you need to enhance your electrical knowledge. If this, as this is electrical, this is related to electrical, I am using that word. And estimation, how to do estimation, right? So that's what I think we have to discuss. Over to you, Lakmal.
Yeah, Kaushal, I think you brought the good starting. Actually, I think the question is very important for the starting also, and you have given a good foundation here. So now in your summary that your thought that when you're doing the as a fresh graduate, so the follow the things, follow the standard is needed, and you must always need the updated and follow the procedures. And so actually yes, if we starting with the thumb rule like this, because people are people are liking to use those thumb rule, but it is not the way. So good point, Kaushalya, you highlighted for the fresh designers who need, if they need to do the design, that's a way. Yes, I think with that my next question will be, I can easily direct to the engineer Kujana, because now these questions actually now engineer Kaushalya has clearly explained so what to do for the best graduates and best design engineers when you are doing the elections and what a SLD single line diagram. Now you as a senior consultant, especially for the electrical consultants, so you are the one who is reviewing the designing, especially for the SLD diagram. And now is it like this? Now you have been received the final product of the SLD, and when you reviewing this one, where is your red pen is gone? I'm asking the where you mark your errors for the student, and what the things you can immediately tell your designers. Don't do this like this. So what is your advice, Engineer Kujan?
Okay, Engineer Suru. When we see the single line diagram, SLDs, basically, let's say we start from the top of the, let's say, SLD, then basically we found, I will briefly explain, basically we found, let's say, main breaker. Then you know that there are few details we have to mention in the main breaker, that is breaker, that particular current, nominal current, and 4 level of the breaker. Basically, most of the drawings we can't see this 4 level. That is important part. Sometimes, as engineer Kaushal said, that we can't use thumb rules. Let's say when we our first design maybe 1000 kVA transformer, then design A, design B, the next design maybe 160 kVA transformer. Then definitely that 4 levels differ. Then we can't directly copy that. Like that, we have to calculate and mention it. Once you practice several designs, then you can say directly, but that particular detail need to be there. Otherwise, a lot of in the implementation stage, there are so many issues. The contractors may face so many issues, then client also face so many issues without these particular details. Then when we come down to the SLD, then particular breakers, let's say switches, coordination. The particular coordination, we have to see whether coordination properly being done. And again, that the cable selection, as per the cable selection, cable sizes, and with the particular cable sizes, those are matched with the breakers, the particular thing we have to see. And also, you know, that protective conductor, cable, earth cable size. That is also very important that just we, as a practice, whether we are doing as a practice, we do the cable sizing or we do the equation, adiabatic equation, or whether we are using the tables and get the earth cable. Anyway, that those are the areas that we have to directly, we can see whether this SLD is proper SLD. I think we can see like that. Other than that, I can see whether the speeds are used or like that. Those are the maybe additional details. I think Engineer Suru, very briefly, those are the details we have to see. That particular details are there when we are reviewing the design like that.
Kujana, before moving to my next panelist, I just want to bring you another attention. So can you add about the switch gears? So when we
Engineer
sizing the switch gear, yeah. So I'm asking any advice for when we selecting the switch gears, the breakers. I'm asking the circuit breakers, MCCB, RCB, like this.
Yes, that it is when we selecting the switch gears or RCCBs and then basically we mention the particular parameters, and maybe sometimes I need to add that even tripping time also we have to mention like that. Then you mean that selecting, there are in the market, there are, I know that when you select the switch gear or let's say RCCBs, there are a lot of products. Then we have to have very good knowledge about how we select this particular protective device in our system, which place we use this product, whether that is matched with our design, whether this protective device is protect as we want. Those are the things we have to see. In doing so, I think proper selection of the good product, that is also challenges.
Yeah. Yeah, thank you, Kujana. I think yes, with that initiates starting with the Kaushalya, and you complete these the things, and he advised about the things to do, follow up the postgraduate, and you as a consultant, what sort of things you expecting as a consultant when you are selecting the SLD diagram. Basically, the cable sizing, the breaker sizing, and the things is most important when designing the electrical system. Yes, thank you, Kujana. And the next, I would like to bring Engineer Danushka for the discussion. Yes, Engineer Danushka. Actually, so I just need to move you for another thing in the sense especially for the electrical protection and the power quality is one of the key factor when we designing the system for the building. So with so many, I think we are using for the power quality that we use the harmonic filters, VFDs, and especially for the LED lighting, especially for the modernized building. And those are the nicknames, the harmonic filters and the VFD and LED lights. Can you share the specific memorable things in your experience, in your industrial experience? Those for that particular harmonic distortion was so severely affected for the buildings that trip or the critical system, how much how much this question has diagnosed. So can you share those experience in your industrial experience?
Yeah, good evening, everybody. Just just rather than giving an introduction about the VSDs and how important it is, like, I hope everybody understand during the course what is the harmonics and how it generates and what are the causes. Just jump into your question directly, like over the past like 14-15 years of experience in the industry, I recognize like about 10-12 years ago, like when the people are introducing the VFDs and LED lighting into the system, early days, like I came across one major issue in a apparel sector office complex. It's a big office complex in apparel sector, and they have been using a server rooms, and there are the office area sample machine areas, like sample, they are doing the sample, so the machine lines are there, the pumps are there. So the most common the complaint we received was when the pump got tripped or some other heavy equipment got tripped in the building, not in the circuit or not in the same feed. Actually, the server is getting tripped. This is even after the UPS server is fed by UPS, but whenever there is any sudden interruption, the server is break. RCCBs are getting tripped. So this was earlier. It was typical to use like typical RCCBs, like normal RCCBs what you see available in the market. So those are the days that the special RCCB was introduced, like SI type on Schneider, but other brands also had. So we introduced that one also. So and it reduces the noise and stripping a little bit, but it was not giving the 100% solution. So we had to like check the whole system, and then identified there are a lot
Sorry
of,
for the interruption. You, I think the maybe the one question came from the chat box.
Yeah.
Your voice is little bit down, but can you voice up?
Okay. So I hope the previous ones are clear. The issue I was mentioning is the server RCCBs are getting tripped due to the system interruptions, like due to motor tripping or something like a large equipment tripping due to earth faults or other overloads or any other tripping. But the server room RCCB was getting tripped. So then we introduced the SI type RCCB, which was designed to cater a little bit of this kind of situations, but it did not solve. So later we analyzed the whole system and understood there are like a lot of harmonics generated by the lighting, especially the VFDs. Those days VFDs also came without harmonic filters. So the system harmonic level was like 20-30%. So whenever there is a tripping happens, the voltage harmonics goes high, and then because of that, the RCCBs tend to switch off. We call it noise and stripping. This is happening especially where already harmonics is available. So whenever there are like harmonics in the system, and if there is a nuisance, then tend to trip. So it's a one occasion. And later I came across another incident, which is a small incident, but it's an interesting incident. A customer complained, another garment apparel sector customer complained that because of the lighting, their photocopy machine touchscreen is malfunctioning. Lights, normally we call it physical, right? So how they identified that was earlier the issue was there, so they were try to find in the solution. Ultimately one day they switch off the lights, and then the issue got solved. So I was asked to come and look for the issues and make the the problem, correct? So when I go there and check the system harmonics, the lighting system is generating like more than 80% harmonics. And as you aware, like most of the LED lights available in the market at the moment are like the power supplies are like third quality, not to the standard. Those are not, if you measure even a branded power supply, what we are getting in Sri Lanka are generating more than 40% harmonics, especially for the small lights. Like for high baits, yes, of course, mostly it's less, but for the small lights, the harmonics are very high. And also on top of that, most of the power supplies don't have a earthing point. So because of that, actually, the lightings are operated and different voltages level and generating a lot of spikes. And those spikes actually creating EMC. I hope you have heard of EMC, electromagnetic interference, and the compatibility. Though because of that, it generates an EMI, the waveforms, and that affecting the printer's touch screen. It is not coming from the power supply, because there are the DC power supplies, DC capacitor, everything is there to filter out. But because of the environment, the touch screen is affected. So what we did is we introduced separately earth all the light fittings, and that has reduced the issue. So likewise, there are incidents which are like coming due to harmonics, which are not, directly we can say, okay, this is because of the harmonics. There are like those kind of small interruptions coming on due to harmonics. There are major issues coming like with the neutral overloading due to harmonics level. The neutral current, the cable is getting very heated. Those aspects are also I have witnessed in the industry. That is also one important point you have to consider, because I have been to many industries where the systems have designed by the supply and designed by the Indian consultants, Indian parties. There are many Indian companies in Sri Lanka operating. So those systems were done by Indian consultants. So Indian consultants, what they tend to use, if you see, the neutral is half at the major points. From the major cables like transformer to MSP to main feeders, the neutrals, they have made it half. Because when the balance system is there, the neutral is very less, so you can reduce that. But what happens when the neutral is the harmonics presence, this tend to heat up the neutral cable very high. So that is an evident in the industry. So that thing you have to look into. If you have, like in the standard, it says if the harmonic level is more than 40%, you have to double even the neutral. So that those things you have to look for. And whenever there is like not continuous, not regular nuisance things happening, most of the case, the harmonic is the culprit.
Yeah, Dhanushka, I think good that you answer. But just to add the one thing. So now, yes, as you mentioned, now it is the most popular. Now it is very important that between the power quality, maintain the power quality in the building. So now, apart from that, so now in my question, that another part that about the use of LED lighting, how this building load, the lighting, the building, the total load is impact with the use of LED lighting.
Yeah, it depends on of course, it is evident, and it is know that LED generates even whatever the quality products you purchase in Sri Lanka. There are harmonics in lighting, right? So that you can't avoid unless you put harmonic filters for the DBs, which is quite expensive affair. So there will be harmonics, right? So how how much important is depending on the total load based on the load percentage.
Yes.
Somebody's
So can you unmute this index number 79?
Yeah, I will continue. So,
Yes, you can continue. Yeah.
so it's totally depending on the load percentage, how it impact to the load. So normally, if you consider an industry where the very large loads are there, so this lighting load will be very less. So the impact on that kind of a system is somewhat less. But when it comes to office complex, office buildings, the residential buildings, especially the apartment buildings, you can see the effect is very severe. So I would say little indication that you can find how the harmonics is impacting on, especially if you are working with apartments, you go and check the neutral to earth voltage, right? You will come across very large voltages in most of the apartment buildings, sometimes even 20, 25, 30, 50. I have witnessed even 70 neutral to earth voltage presence. These are majorly due to the harmonics in the system. One thing is the inverter type ACs, the other thing is the lighting load.
Yeah, thank you, Dhanushka. I think the very descriptive explanation about these power quality and the harmonic filters things. Yes, I think we have covered these with the all of our expertise with the first round. I think the session is open to the participants who are joining with this Zoom, because this is your session, not for my end to ask a question. I'm representing you to get questions so can deliver into the and direct into the panel members and get the answers. And rather than conducting me, I just want to hear your voice as well, because I know you have so many questions and so many sharing and things to be clarified from the distinguished panel members. So the session, the forum is open to you to raise your questions. I think you can voice direct to your prepared panelists. You can raise the questions. I think now from now on the session is open to you to raise a question. So,
Engineer Dhanushka, I'm Upul. Can you hear me?
Yeah.
That is about the harmonic, that is harmonic and harmonic filter. So you said that LED lighting connectivity is sometimes equal to harmonic, higher harmonic. So
Yeah.
how we can overcome that one, and what is the ratio of that increase in current of that harmonic?
Yeah. The typically, if you get a commonly available, it's if you go to the industry, like everybody is using PETA. Most 80% of the people using PETA or novel light billing, right? So what you will expecting around like more than 40-50% of the harmonics, like even if it is like 10 watt or 15 watt, even more, right? So very high harmonics are there. So the one thing is to eliminate how, as a designer, yeah, of course you can specify, right? So in the specification, that has to be mentioned strictly to follow the harmonics level to a certain, at least to a certain level. I know industrial standard says less than 5% for the power harmonics, but you can at least for the small power like 10-15 watts, if you can achieve like less than 25%, that would be much better, right? That is on practical, not on the standard level. So that kind of specification you can prevent. The other thing what I normally follow is like use in the specification, I specify the NERD certification, where in the NERD certification for the light fittings they measure the harmonics. So from that I can do the selection. That is how you prevent it. When you already install the harmonics, then it's a different ball game. it's very hard to reduce the harmonics using one thing is technically theoretically the use of passive filter, but I haven't come across any passive filters used in the industry for harmonics. So what I have seen at the moment, like in future, I would say there will be harmonic filters at sub-distribution levels. But what I see now in the new industry, especially the large industries, for the main panel boards, they are using harmonic filters just to prevent circulating the harmonic current to other feeders. So what will happen is when the harmonic current is there, the voltage also impacted. So that voltage is affecting our entire system. So to prevent that, we usually what we see is like in the MSB level, we have the active harmonic filters, and also it is getting mandatory to have harmonic filters in the HVAC panels. Like you have a feeder for the HVAC, then that has to have a harmonic. So that way you can reduce the harmonics in the major equipments. So your affecting on system with the lighting harmonics is very less. So that way you can minimize these issues. So you can directly reduce the harmonics in the LED lights, but you can reduce the other system, the bigger system you can reduce, so the impact is low.
Right. I think if I correct the name, the Upul, I think I think you have been correctly answers for the questions.
Yeah, thank
Yeah.
you.
Okay.
Engineer.
Okay, and thank you, Danushka, and thank you for voicing for the participants like this. So you can raise your whatever the technical things and technical clarifications, and also not only that, whatever the experience you can share with these panel members and the participants. Okay, my next question to Engineer Kaushale, who's our distinguished the lecturer of the session. And now I think Kaushal, now we have come to the good point now. So starting from the cable single line design and the how these correctly sizing the cable and the breakers, and also Danushka mentioned about how to maintain the power quality. So in order to do that, so initially we should have the building load. That's the initial point that we have to do. And now I'm not going to ask this question, but because you have taught clearly how this is calculated. Now my questions now, how shall I now, in your thought, that selection of transformer and the generator is a generator in the secondary power supply for the building. That's are the lead the loan lead items and the high cost item for especially for the electrical system is concerned. So how do you convince the clients when we selecting the transformer or the selecting the generator for the building? So what is your guidance to the client when you do this, especially so I just want to highlight about the building future expansion, as well as the now in a future trend about the EV charging is coming to the picture like this. So what is how do you convince the clients as a senior consultant of this in the field?
Right. Thank you. And yes, a good electrical distribution system should be able to scale up, right? So that scalability should be there. So when you are before you are doing your design, so you should gather details on what are the expected expansions and what are the time frames the client is expecting them to accommodate, and what type of expansions to be happen. So depending on that, So your distribution design shall be do it in a way which can scale up in the future, right? So if you have done some investment, and if you are going to get an expansion in next 5 years, so that investment is not recovered yet, hopefully. So in that case, you should have an idea, and you should do your design in a way how to scale it up. Let's take an example from selection of generator, right? So if you want to minimize the initial cost, you can divide your system to emergency and non-emergency, and where your generators should come, and what loads that does not need to be operated during an emergency, and you can segregate them. Other than that, so if you can keep some provision to incorporate another generator if it is necessary in the future, that means in the synchronization panel, if you can keep a provision, like you know that most of the generator manufacturers, they provide their own synchronizing systems. So those you have options to select how many generators that you can incorporated into a particular system. Depending on that, cost varies. If you have a plan to increase the capacity, so you can spend a little more and take a synchronizing system that is scalable to your future requirement. So weighing up with those, you can have those options. If you are selecting transformers, that's pretty tricky. You may be going out of LV meter supply to HD meter supply in this case. So then, of course, if the expansion happens, you may need to add another hierarchy of medium voltage system and have the same transformer and the same distribution for the existing, and can have a different transformer and another main switchgear panel for that portion, because your system metering will go from low voltage metering to maybe high voltage metering, if so. If not, if it is still going to be there at low voltage metering, so you shall have another distribution board hierarchy at lower level, and shall segregate those to another SDBs like that. So for that, you have to have provisions at your location. So that depends. So all these can be considered, and take your right decision of allocating spaces and allocating electrical infrastructure to make it suitable. If the expansion is coming very early, maybe within a year or within less than a year, you may think about incorporating or designing the system to suit that as well. But you need to make it sure during the operation you are not going to face any issues. We'll take generators again into an example. Let's say currently you have 500 kVA generator, and another 300 kVA is to come in future, maybe in less than an year. If you buy 800 kVA now itself, catering the minimum load can be an issue, and there can be a significant damage that can happen to your generator. So in that case, rather than having a single generator, you can consider to have set of generators, multiple number of generators, equal capacities or different capacities. No problem, you can sync them. So there can be so many things that you can do, but that everything has to be taken care by deciding the capacity and the time frame that the expansion is going to happen. Is that okay?
Yeah, I think yes, you have clearly explained about these things to the things. Thank you, Kaushalya. Yes, now actually we have good in alphabetical good order. Now it means now we did we discuss about the sizing, the selection, how to do, and how the things to be considered, and what are the things we should maintain, the how to power quality. And then back to the by Kaushalya mentioned about the based on the load, how we can plan the transformer generator considering the future expansion and the other things that the client requirements. So now I would like to hear from the question from the audience if there's anything. I think so yeah, okay, it's okay that you put in the chat box. Actually, we are mostly welcome, and also I would like to hear your voice as well from the audience. If you can even with that time that your voice can be open to the panel members. So do you need anything to clarify? So I will take these chat box questions while this is going on, but I would like to hear from you. So anyone from the audience to raise your questions? Yes, the one question from the I'll ask from the Kaushalya, because now it is related to you as well, and in your explanation. Now simple question asking from one of the student. He mentioned, I think the Dhanushka also answering the question. Now the bending radius about the cabling. So it means he mentioned the 8 times into cable diameter. This is a common practice, or any comment on this? I think Kaushalya, can you answer this one? Yeah. You are muted, Kaushalya.
I'm so sorry.
Okay.
And apologize. Bending radius, that of course differ from voltage levels, as well as whether your it's a fixed installation or still you are doing the installation. Depending on those, this bending radius differs. Generally, up to 3.3 kV. If it is a fixed installation or during installation. For circular conductors, that means the core, if the core is circular, you should not go above 6D. For sector-shaped conductors, you can go for 8D. D is the diameter. Right? So for circular conductors, 6D, and for sector-shaped conductors, 6D. if it is moving towards 33 kV, for fixed installations, you are limited to for single core 15D, multi-core 12D. During installation, you can go up to 20D for single core and for multi-core 15D, right? So when it is going towards 33 kV, during installation, 15D for 3-core or multi-core, and fixed installation, 12D. For single core cables, up to 33, from 3.3, 20D during installation, and 15D during for the fixed installation. I hope you are clear.
Yeah, I think the correctly answers Kaushal. I think that's what that particular participant clarified. So he's mentioning about the bending radius 8 times to cable size. I think you have correctly and description you clear that question. Thank you, Kaushal.
Adding into one little thing,
yeah, Dhanushka, yeah.
like depending on the cable material also, for example, if you using low smoke halogens, LSHF, the stiffness is high. So if you bend as per normal cable, there can be micro cracks. So you should always follow the cable manufacturer's recommendation also on top of the general practice. So sometimes you find it like some manufacturers don't allow to bend too much.
Right. Yes. Thanks to gentlemen the descriptive explanation about the participants' questions. So I would like to bring Engineer Kujana for the scene. Engineer Kujana. Yes. Actually, now we discuss about the in sequence wise about the selections and the power factor and the power quality and the also the load and how to do the especially, and one important point is the earthing. I think earthing matter. I think I remember. So you have good experience and you have good explanation because maybe I remember, and you have engaged one TV program in recently about these lightning protection and everything. So my question is like this, Pujan, now. Actually, so in the course, actually, the Kaushalya is very clearly covered those things. So now this practical aspect on the high rise projects, we have different contractors. It means the structural contractor, the civil contractor is there, the MEP contractor, and they are doing the lighting protection as well. So so in your consultant experience, so what is the most overlooked bonding point, and that end up to the casing for the dangerous in touch voltage, for the situation for the during the commissioning. So especially I'm asking this, if you simplify the question, so especially that particular earthing and that bonding matter, how do you ensure that during the commissioning, especially because the MEP contractor use the structure for the bonding for the earthing matter. So how do you ensure that this bonding is well established for the building?
Okay, Engineer Suru, I think you mean that basically with the lightning protection system you
Yes.
mean, no?
Yes.
Okay, then we know that in our lightning protection system we need whatever the exposed conductive parts need to be connected to the lightning protection system. Let's say in a rooftop, let's say about 20-story building. In the rooftop, we have a lot of services, exposed metal structures are there. We have maybe AC cooling towers, AC outdoor units, and we have some metal ducts from kitchen exhaust, and there are, that stairway pressurization fans are there, rooftop area like that. We have water tanks, basically, then water tanks, ladders are there, steel ladders. But the particular, all the things need to be correctly connected to the lightning protection system, that down conductor system, which is in the rooftop perimeter wall. And other thing is, I think, when we consider, let's say, 20-story building, let's say apartment building, we have a lot of, balconies, and handrails are there. Some windows are metal, aluminum windows, handrails are there. Then the particular handrails need to be bonded with the down conductors. Basically, that is which I am referring, that structural down conductors, which is going through the structural columns, separate lightning down conductor. That particular handrails and whatever the exposed part other than the rooftop, below floors as well, need to be connected to the down conductor inside the building, inside the reinforcement, inside the concrete slabs and columns. That need to be, then we can avoid the touch potential voltage. Then rooftop is covered, then whatever the latter part, then ground floor. Then when we come to the ground floor, we know that we have text boxes, so whatever the test bit locations are there. And also we know that in our text box level, there are possibility to that touch who the person, they can touch the particular down conductors. Then also that we have to keep that particular insulations and whatever the precautions to avoid that. Those are the things, I think, because the thing is, you mean that structural contractor may be differ from the lightning protection contractor. Some projects, but we prefer same contractor. Anyway, if there's two contractors, floor by floor, we have to do our inspections whether the particular bonding points, clamp or cadwell, bonding points, whether they have done properly. That is, I
Yes.
think, I'm covered.
Yes, Kujan, I think that, yeah, thank you. That mostly covered. I think things is especially the how the things to be connected, especially for the structurally, how these the lightning protections and the earthing and the bonding to be done. Thank you for the explanation. So I back to the Engineer Danushka. I think to the discussion. Danushka, now we have in the chronological order, we have come to the system design and how the load is. Then we have for the design for the selection of the generator, transformer, how to do that, and as well as the earthing. Especially, so my the questions goes to you for especially when we selecting the panel boards. Because we have the different type of the distribution board. We call we have got the main distribution board and sub distribution boards, and so now in my experience as a in this field, the even I cannot understand where this mistake happened. So when we select in the panel board, so always it cannot be approved in the first time from the consultant, there are so many dragging points. Maybe the quality of the publication, or maybe the certifications. And so what the things you can advise for the audience and the viewers? So when we selecting the panel board, especially for the main distribution board and sub distribution board, so what is your advice for the team?
When it comes to, I hope audible, right? When it
Yes,
comes
yeah.
to the panel board, which is actually one of the major item in the system, but mostly what I say is which is lightly taken care of, like especially when it comes to standards. Like technically for panel boards, you have to follow. We follow 61439-1-2 standards. Most of the panel manufacturers in Sri Lanka. Okay, just give me 2 minutes until I plug in my laptop.
Yes, right. The reason why I am raising this question on behalf of the audience, so I think so I just explained the practical solution from the Danushka. So how we can, because he has a lot of experience in this industry. Yes, Danushka, please over to you.
So, so what I can say is like mostly in the standard we specify like 61439 we have to follow and comply. But most of the manufacturers, what they do is like they give certificates, but actually it does not comply 100%. So I would like to say like the real standard when you have a certified panel, it has to strictly follow the design guideline when you the panel what you send for the testing. So this is like not like other product testing. In the product testing, you have some parameters to follow. So for example, in the cable, there are technical parameters given. Okay, you have to match these diameters. This is the quality level of the copper, those things, and insulation level. So once you meet those things, and when you do the production, and always that standard complied. But when it comes to panel board, it's different case, because every time you make a different panel board. Very rarely you make identical panel in every project, even in the same project, but also you continuously build a new panels. So one panel to another is different. So the how to take the certificate for that kind of product is, earlier we used the type tested, but now it is like complied standard which you have to follow. So you have to send a panel to the testing center, and when you are sending, you have to follow a design guideline. So that design guideline you have to follow when you do make the panel also. Like what we do is, when you send a panel, what we do in the certification, what we do is, for example, we take 4000 ampere panel board, right? What we do is like we put the main breaker and design the bus bar and several outgoings. Like let's say we put one 3200 outgoing, one 2500, 1000, 1800. Likewise, we can configure ourselves. There is no guideline to follow this. This is the incoming, this is the outgoing you have to have. We can test our panel. So most of the manufacturers, what they do, they try to cover all the breaker capacities and like 5-6 breakers into the panel, and then they send it to the testing. So in the testing, there are 13 number of tests they have to follow. Some tests they can omit based on design calculation methods, verification methods, and some testing you have to mandatory follow. For example, the most critical test for a panel board is the short circuit test, the temperature rise test, and the creepage test. Those are the most critical stuff. Creepage test, actually in the design you can comply easily, but the short circuit and the temperature rise is the most critical failure points when you do the testing, right? So what will happen is like if you do small changes, the performance will vary. Like same configuration, let's same breaker, same incoming, but if you change the bus bar arrangement, or if you change especially the bus bar support manufacturer, let's say you are using a one good brand for the testing, and in the production you change the bus bar support, then this kind of panels can fail in the industry. So those kind of critical components are there. You have to follow in the production as well. If you get the certification with the bus bar support, you have to use the same bus bar support in the panel. So likewise, there are critical items, especially in the design configuration. For example, the gap between bus bar and the ventilation holes, those things will critically affect the temperature rise test. So it's in most the major case of failure of the panel board is the temperature rise test. So this you have what the panel manufacturers do is like they try to reduce many components in the panel board it should be, but they send the basic panel and put lot of ventilation holes in the panel, right? So that is how they achieve the temperature rise in the testing. So what will happen is like when you do the production on the same panel based on the same certification, they don't use that ventilation. So what will happen is ultimately the panel temperature goes high. So likewise, there are many issues that can happen in the when you do the panel board manufacturing. And also another important thing is like when you issue a panel certification or testing, the panel board the test certification lab, they issue the rating as well as the breaker brand. So that is also very important. If you tested the 4000 ampere panel board, it doesn't mean that you can use any breaker, and even you follow the same guideline principles. The panel board behavior will change with Schneider breaker. There are many models even in the Schneider. If you use ABB, the behavior will be different. If you use LS, the behavior will be different. If you use Siemens, the behavior will be different. So the most of the time, the temperature rise test will fail. So likewise, if you want to 100% comply on a panel board testing, you have to have the certification. If you're using a 4000 ampere panel, then the panel should be tested for 4000. On top of that, if you are using the Schneider breaker, then the testing should be done on the Schneider breaker. So if you go for a major manufacturers of panel boards in the world, you can go to the websites and you can download their testing certificates. They issue testing certificates for same rating. For example, 4000, they issue ABB a separate certification, for Schneider separate certificate, likewise. So that is how important when it comes to if you want to 100% comply with the panel board standard. But in Sri Lanka, what you get is like there are a lot of loopholes available. So they use those loopholes. They say it's certified, but what ultimately you are getting is not 100% complied to the certificate. So very important when you do, especially about 3200 rating panel boards, you try to go for a type tested panel, and it should be properly checked that panel board is correctly made. So it's very, very difficult to identify those issues, but with the practical experience and the knowledge, you can identify what is the correct panel code and what is the there are complied panel boards in Sri Lanka people make. So that differentiation you have to take, and that the decision also on your hand whether to go for 100% tested certified panel or complied panel.
Yes, good eye-opening explanation, Danushka, you have done. So I would like to engage Kaushal also for the discussion. The Kaushal, I think with that Danushka explanation. So now he mentioned. So in my I catch one point that above 3200 ampere it should be certified and it should be compliant. So in Sri Lankan LV distribution aspect, so as you as a senior consultant have this, so it is really happening now in industry. And also no, actually now okay, if you are, if I sorry that if I am putting into the trouble for this question, no, if unless can you tell in connection with the Danushka how importance of getting the certified panel to the building?
Yes, that is very important, right? So as Danushka said, when these standards are renewing, so many types of tests were included, right? So when it is by today, you have type test certificates. If you take a switch gear, there are about 13 entries, isn't it, Danushka? Yes,
Yeah,
about
13.
13 tests to be carried out. Some of them can be done by calculations, some of them by proofs, and some of them they has to be tested from a third party laboratory,
Yeah.
right? So why is that there? First thing, we are again coming to that thumb rule question, right? So when we are making a panel board, there are some myths among some panel manufacturers. Let's say the amount of copper that he is going to deploy inside the panel board is going to take care of everything. No, that's not, right? So if it is a 3200 ampere main breaker, he is going to deploy 3200 ampere supporting amount of copper as a cross-section area inside the panel board. That is not going to work, right? When it comes to a distribution board, a switchgear assembly, the right technical word, which comes under 61439. Those switch gear that in circuit breakers 947, you have 2, 3, 4, and so on, right? Under 61439, part 3 gives this switch gear assembly designs. All the other parts you need to be followed for designing the switchgear assembly. And you need to check what are the thermal capacity handling, the short circuit capacity, what are the internal arc ratings, and what is the contribution you need for seismic tests. And there are lots of things, right? By just having that amount of copper is not going to do that. Let's take an example of an arc flash, right? If an arc flash happens, how long that is going to be sustained in the panel board decides what is the heat energy discharged and the shock energy discharged. So sizing the right insulator, the amount of space you are going to maintain within bus bars, and what are the tripping values, that means the current values as well as the timing of your circuit breaker is going to come into the picture. Very recently, we developed, I think I showed that particular RFQ, the specification during the session, maybe the last one. So that we have requested type test certificates for internal arc ratings, short circuit, circuit breaker type test certificates, and so on. If someone is not be able to provide those type test certificates, they should do a realistic calculation, at least how to prove that, right? Because most of the panel manufacturers here in Sri Lanka, some of them have complete type test range, but some of them may have not. So we have to select someone from the available set of manufacturers.
Yeah.
Right? So that's pretty tricky. So the first thing is we have to look, am I audible?
Yes,
My
audible,
connection?
audible.
Okay. So first thing is the safety. The person who has given us the authority to look after him and the community that he is going to serve has to be safe. That's the first thing, right? So because of that, those certificates, testing and all is necessary. So during the site, there are very limited number of tests that you can do during commissioning. All the others will have to do either in a laboratory or at manufacturer's place. Even at manufacturer's place, those short circuit tests and arc rating tests will not be able to carry it out. So those has to be verified by a laboratory. That's why those IEC certified laboratory like KEMA certificates and so on are there. So these bodies test a sample and give a pass mark. But that includes what are the type of switch gears, what are the models, what are the bus bar sizes, what are the insulators. All these accessories should also be incorporated if that particular panel builder is selling some product. All of these accessories has to be used. As Dhanuksha said, as he mentioned Schneider, I'll also take an example. So you have, if you take Schneider, you have, for the time being, 3 ACBs. One is the Masterpack MTZ. The other one is Masterpack NW and NT, which is retiring very soon. And the other is EasyPack variant of the same. So the Masterpack MTZ and Masterpack NT and NW shares the same platform, whereas the EasyPack ACB is different. If someone is going to offer a product which has gained the type test certificate through the Masterpack series, instead of that, he is going to use EasyPack, then there's a major failure. That is not accepted. Right? Now there's an amendment to 9472. If the same brand is used, that can be replaced with another breaker, switch gear, not switch gear, the circuit breaker from the same brand which has equal type test certificates. There's a new clause which has been incorporated to 9472. So I will not going to discuss what happens in Sri Lanka, And this is required. This is extremely necessary.
Yeah, I think very good topic, Kaushal and Danushka. If we have discussed a really interesting topic about that you brought into the discussion. I myself would prefer to ask more, but the time is a key factor and the limiting factor. But anyway, so I thought of having another kind of the CPD courses, especially for the panel board designing like this, and we'll discuss in the future. Okay, Danushka and Kaushalya, you can be here, and I'll bring Kujana for the discussion. For the one important point, Engineer Kujana, I think you are here. Yes.
Yes, Engineer.
Okay. Right. Engineer Kujana and Engineer Kaushalya, these questions is both to you. I have the two different questions, simply asking and give the short answer because we have few things to cover at the time here. And one is the actually, so I think you are Engineer Kujana is a freelance consultant, and also the Kaushalya also is a one of the consultant. So when you're designing the LV system, so I don't know how this is your experience, right? Not for the Ramruna, because I think especially Kaushalya mentioned from his word, he doesn't like to go with the thumb rule. Actually, this is not the thumb rule I'm mentioning. So what do you think? What you consider about this, the diversity factor? I don't know whether you can answer this question in a practical way. So when you design the LV system to the building, so how do you use this fact? Now I don't. It doesn't mean that I just don't want to mention about the figure, but how do you apply this name, that word diversity factor, to the design?
Okay. Okay, Engineer Suru. Yes, diversity factor that directly in our previous discussion, there was Engineer Kaushalya explained that selection of the transformer and generator, that is the main item of our LV system. Then if we properly do our diversity factor, then we can have end of our design, we can have basically a lot of saving to the client. That is the main thing. Otherwise, our designs may be over designs. So that is diversity factors. We can't say you have to use this factor for this building like that, but general scenario I'll explain. Let's say in our industry, buildings like apartments, then commercial buildings, under commercial building, let's say offices and hospitals, and say supermarkets, and again buildings. When we take the one example, I will take apartments. Even when we do whatever our load calculation, there are points, I think, in our course. Engineer Kaushalya explained clearly that there are points in our calculations. We put diversity factors. Then if we do proper diversity factors with our experience, even that past experience and past analysis done through we have some analysis for the particular building, install capacity of the transformer and generator. Then there are there is other figure that is usage capacity, like that. Sometimes we may have, let's say we have 400 kVA transformer. Throughout the year, if we see the figures, the particular load may be 160, 200, like that for apartments, very less load. Then even for the, when we are doing, I will very briefly I explain for the in our design, even for the apartment, we have to see this particular apartment is which category, and whether the apartment is going to be built in Colombo area or outside of the Colombo. Like that, there are a lot of things we have to see. Accordingly, we can have the proper diversity factors. Then again, we come to the like building like hospital. Then we can't do like apartments, we can't do our diversity factors for the hospitals, because even for the hospital we have to see whether this hospital in which range, are there any theaters, lot of theaters are there. Then nighttime load may be very high if it is a private hospital, and even that also we have to consider if a private hospital or government hospital. There are a lot of things we have to see when we are putting the diversity factors. Uh, and again for the factory building, again that we have to see the what are the, we collect lot of loads from the other parties for when we are designing the factories, machine loads. Like that, time to time, project by project, uh, we have to decide this diversity factor practically. Otherwise, we can't say this project we have for apartment this diversity factor. We can't say like that. Number of apartment that matter. Let's say one building may have 20 apartment, other building 400 apartments. Then our diversity factor totally change. Those very briefly, Engineer Suru, that is my answer. Right. Okay.
Yes, Kujana, thank you. That stay online while we pin Engineer Kaushalya for the scheme. Yes, I think together you can answer this question actually. So while glancing through these diversity factor from the Kaushalya, I think that you are as the senior consultant in the industry about especially for the electrical system. Now, the back to the standard. Actually, now if you compare the standard, the common word is a BS 7671. That's I think as far as I know it is a, so there in addition to that there are some IET standard as well. So now the one participant also raising the one question, so I'm engaging this question as well. So now how this standard, especially for that particular BT standard BS 7671 is coming to the picture when we do the entire electrical system designing, maybe the cable selection, maybe the equipment selection. So very briefly from both of you, starting from the Kaushalya, just give the brief about this the role of the BS 7671 or whatever the standard, especially practicing in Sri Lanka. Yes, Kaushalya.
Yeah, sure. BS 7671 is not the Bible. First
Yes.
thing, right?
Good
BS 7671 gives you the name if you extract, that is requirements for low voltage installations, so that it doesn't cover everything. If you have a look at it for the electrical load calculations, what are the entries BS 7671 provides? 1 or 2 pages are there, right? So they have given you what are the simultaneity factors for residential, industrial, and commercial. Apart from that, what are the demand factors and what are the sub-diversity factors at each level? There's no detail in that. If you take the BS 7671 on-site handbook, you have more entries than the BS 7671 the technical guide. Depending on this, what you call electrical design estimations. When it comes to this estimation part, you have to link with some other few standards. If the BS and IEC or BSEN is taken, especially sizing of this switch gear. Danushka and Kujana both may be intact with me. So sizing of this switchgear assemblies 61439 gives you this RD factors which you need to be considered at each level. What we discussed during the load calculation session. And apart from that, the guidance is there at the BS 7671 and the reference for another standard is also given there, right? Creepage distances and all, if that is being taken, there's a reference for IEC 61439 general part 1, right? If lightning protection is taken, designing of lightning protection is not there in BS 7671. The link is there for 62305. SPD selection, a very limited guide is there. A reference is there for other IEC standards. RCCB, where to use RCCB and when to use RCCB is there. The selection of RCCB is not there. So another reference to 61008 or 61009. Likewise, a set of standards which is related to low voltage equipment, devices, accessories is there incorporated in BS 7671. So taking BS 7671 alone is not going to give you a in-depth understanding or in-depth detail of doing an electrical system design. It is associated with many other standards. So that's my view towards the BS 7671.
Yes, thank you, Kaushalya. So I think normally if I ask Kaushalya in very brief, that is a Kaushalya brief. He's taking much of time. Thank you, Kaushalya. And
Sorry.
Kujana, the Kaushalya mentioned about this BS 767 is not a Bible. So what do you think? Now actually, so what do you can add to the Kaushalya's explanation?
Okay, I'll add one small example for that. Let's say our calculation after the load calculation, our transformer size final load calculation is 450 kVA. Then definitely we have to go for the 630 kVA transformer. If we use our practical scenarios, practical analysis, and what has happened for the existing building, what the particular figures, then we can see whether we can put more diversity factors and redesign our calculations and relook our calculation. And then now we are in 450 kVA. Then if we can drop our loads 370 kVA, then we can use 400 kVA transformer. Then earlier 630 kVA transformer, now we are going to use 400 kVA transformer. That is the very simple answer. BA7671 is the not to buy.
Yes.
Okay.
Okay. Thank you, Pujana. So with that, I think I bring engineer Danushka to the scene. Engineer Danushka, I think now the related questions I'm asking because I know that you are engaging with the consulting role as well as the previously you are engaging with the contractor side as well. Now, because the client, even though you are a well expert, so that no industry knows, but client ultimately come to the cost factor. So how do you maintain the design with the comply with the cost effective solution? In simple answer.
Yeah, it actually everything comes down to finance at the end. So everything will be decided by the accountant. So that is how the world runs. So whenever a plant is going to install, the decision will be taken by the accountant, and he's trying to minimize the investment cost. That's the thing. What I can see is like from the practical experience earlier, we told that life cycle analysis, cost and blah blah everything, right? Earlier people tend to use very long lasting products for a long life, like 15-20 years expectancy. The recovery is calculated based on those things. But with the changes, the dynamics, behaviors of the industry and the supply chain, what I came across is like this is purely from the accountant perspective, okay, not the technical perspective. What accountant is looking only for about 5-year time frame. So if the factory does not recover within 5 years time, they will not do the investment. So that is very important when we are designing an electrical system. So try to avoid unnecessary over designs. As a practical example, the experience I can share, like most of the new industries when it comes to Sri Lanka, unless it is like proven industry with the designers and everything, most of the cases what I experience is the plant runs at like 50-60% load from the total install capacities. That is everywhere, especially for the manufacturing industry. So that is common because these things happen because when a new kind of industry comes, as electrical engineers, what we get is we get the data from the production or the planning engineers. The planning engineers, what they do, they get the data from the machine supply, right? So the machine supply, what they do, they give the maximum ratings. And most of the time, let's say the machine, the torque and the everything requirement is like fulfilled by 60 kilowatt motor. When the machine is designed, they put like 80 kilowatt motor or sometimes 100, just to make sure the machine is running perfectly, right? So what will happen is it doesn't make that it will consume 100 or 80 kilowatt, but when it in the practical scenario, it consumes actually the 60 kilowatt. Sometimes the most cases the plant does not run at full capacities also. Like some motors does not consume whatever the rating. That is what I mostly experience. So similar cases, like on top of that, we have to understand the process also. Like most in some industries, unless you go into deep understanding of the process, you will miss some things. Like some process in some applications, the simultaneous loads are not running. In some processes, one motor set is running. When that is running, other motor set is not running. So similar cases are there. So the process also you should understand if you are going to improve to to a good level. Otherwise, what will end up is like mostly the over design cases. From the accounting side, what I can tell you is that if this kind of over design happens, the accountant tend to sometimes the postpone the projects. What I have seen due to the over the larger investment capacity, because of the ROI is not complying, they have postponed the projects. Sometimes they have taken the projects into other countries as well. So it is very important, especially because the Sri Lankan in Sri Lankan context, doing a building is a very expensive compared to other countries around the Sri Lanka. If you go to India, Bangladesh, you can build the same factory at a very low cost. So it is very important that we design the electrical system so that it does not go over design. And I have came across some other cases to add, like what Kaushala said, we have to always keep some future expansion also. So in some cases, when we are struggling to keep those spares, some accountant said, no, I don't need that. So what he only consider about 3 years lifetime, the time period, then he will change it. So that kind of aspect also you have to understand. In some cases, some investments are not going for a long time. Some investments are only focusing on the short time. So those kind of things also you have to consider when you do the designing. On top of that, we have to communicate those clearly, because without just thinking everything into ourselves and designing a system is not good. Whenever you take those risks, you have to communicate clearly to the client and the relevant engineers. So these are the risk factors I'm taking. So that responsibility is shared, right? Otherwise, what will happen is when there is a mistake, everything come back to the engineer. Why you have not designed it correct? So whenever you are taking a risk or a lower factor, those things you have to communicate it clearly to the top levels.
Yes, Danushka, I think, yes. As an expertise in the field, so we clearly identify and explain those who invest, what is this factor and what are the things, and clearly that's the engineering role that you are doing. You all are doing very well in the field. That is clear. Thank you. And also, so we are running out of the time. It's almost past 8. So now the members, the 3 distinguished panel members are online, they're on the screen. So if you have raised additional question from them, you can raise now. So we are coming into the end of the session. Even they are willing to take their time for you to answer questions. If there's anything you can answer, but I know that there are lots of questions are going on in the chat box, and these panel members are keep on answering the questions. Thank you very much. Keep on updating the participant. Even you can voice up here if you have anything to clarify. So it's over to you, the participants. So you can raise your questions. So if anything you want to clarify from these panel members, so actually this kind of session will be rarely organized like the special 3 expertise in the industry. So you can share and you can clarify the important thing that you are suffering at the moment in this field. So anything you want to clarify from the audience? So this forum is open to you.
Get that that power factor improvements of capacitor banks like that. So we didn't touch in this sessions. How about how we can design power factor improvements with the capacitor bank reducing inductive loads. That is, I think it is very important. All the ways they are requesting that the design the power factor improvement with the capacitor bank. I think this is not timed asking that question, but the thing that your expert panel can give some little bit of that one, that is very good now.
I think maybe you are referring for the questions which to be asked that the course is ongoing. I think Kaushal, I think you can answer.
Yes, of course. I think BSI is planning another session on how to design capacitor banks and harmonic corrections
Correct.
and all. Maybe 4 to 5 day session. I don't know. It's their decision. We'll see whether it is coming in. Yes, if this is taken, capacitor banks. First thing that I would like to give you, that this will be a lengthy answer, even though it is brief, Lakmal. I'm sorry. Yes, sizing the right capacitor bank is an issue, right? For that, you need to log your data. Yes, you can pre-design the capacitor bank, collecting all the loads and taking aids of a modeling software like ETAP. You can design the capacitor bank as well as the harmonic corrections. That is possible. The issue is the know-how to do that. If you just forecast, this will be the reactive power necessity of your system, right? If you predict it, sometimes it may be under selected or sometimes it may be over selected, making a huge investment or making a pointless investment at the end. So what I see is best to be in keep provisions in connecting it to your main distribution board and do a power quality analysis when the system is reaching to its maximum demand after maybe 1 or 2 months of operation. You can do a power or electrical survey. Then you can understand what are the limits, what are the kVAR limits, what are the voltage drop concerns, and what are the harmonic distortion of your system. And you can do your power factor correction system, APFRC design according to the requirement. So the first thing is to log your data and then to size your steps. What are the steps? And if you refer the IEEE C 53 something, the guide, you have different formations that you can use. 1:1, 1:2, 1:2:3, 1:1:4, and so on. Not that every combination of capacitors is going to give you the required correction ability. So there is a sequence that you have to follow, right? And how to select your detuned capacitors, what sort of percentage is going to treat to what level of harmonics. So all these should be included in this APFCR design. Apart from that, protection requirements. What are the protection requirements? So what are the delays you have to incorporate? And what are the short circuit conditions that you have to think for? And what are the voltage levels of your capacitors that you are going to select? and what are the duties of the switch gear that you are going to use in the capacitor bank. All these has to be considered, and what sort of techniques that you are going to take for capacitor restriking, right? There's a phenomenon called that echelon breakdown. So those can be happen, and the restriking of the capacitor going to destroy all your capacitor bank. And what types of capacitors you are going to use, self-emission type capacitors or regular capacitors, whatever it is. So that's a very lengthy process, and which is uh, I think there's a more depth than designing an electrical panel board.
Yeah, I
Right?
think Kaushalya, yes. I mean, right now, yes, BSIC is planning to have another course of how to maintain the power quality of the building. That is being planning, and number you will be entertaining in the near future that course. How to maintain the power quality. Danushka, I come back to the point with the in connection with the Danushka, the Kaushalya. Now, I'm asking that same questions now. When we connect into the third party devices for the electrical system, for the energize, because now when this equipment is failed, that pointed out your power quality is not good, your harmonic filtration is not good. That is why my equipment has been failed like this. That because of that, I think the third party devices who are energizing to the system, they will ask them to bring their harmonic filters, the active harmonic filters on their own. Is this right way, or what is this thing? Or give me any short answer, because we are running out of the time.
Yeah, the best thing is to, if a third party supplier, like for example the HVAC or the chiller,
Yes.
to come up with their harmonic filters and whatever the protection, right? Nowadays, the common issue of equipment failure is one thing, the harmonics, and also there are some other silent factors happening, like the sags and swells, which is you can't see on the normal power analyzer or the logger. So it is also a common new. I would advise to use at least one analyzer in the main panel, which can monitor and log swags and swells of the voltages. So in that way, you can log the transients coming into the system, so that especially those sensitive harmonic, the electronic devices sometimes failing due to those things also. So in that way, you have the log data, so you can show it to the people that okay, these are the power quality that we are maintaining, that is the log is there. So I personally advise to have at least one power analyzer which can in the main income line, which can log those data. So by that way you can prevent those unnecessary incidents.
Okay.
Like,
Yeah. Thank you, Danushka. And also, I think the chat box is very active. People, the students are keeping pointing the patient, and the panel members are answering. Thank you very much. So, any questions? You can direct it. You can direct to the panel members. You can voice up. So before ending, so going to the end of the session. So any question from panel members? Any question to panel members from the audience?
until somebody is raising the question, I would like to add something, and I like Kaushalya's feedback also. Like in past few months, like what we have seen is like many fire incidents happen everywhere. Like day before yesterday at tea factory, every week we see fire happen. So the most of the cases the fire comes because of a connection to electrical. So what I like to emphasize is that the use of because we are not using it at the moment, use of AFDDs. especially when there is like the apartments and the hostels, hospitals. So I would like to add some more thing into by Kaushal also regarding the FDDs and the use of those in the installations. Kaushal, your inputs also.
Regarding what was the
AFDDs.
Yes.
Pardon?
The AFDDs.
SPDs.
No, AFDDs. Arc
Ah,
fault.
yes, arc fault detectors. The issue, one thing is we specify, but because of the price, some clients remove those. Right. Very recently, I designed one panel board with arc flag detection, arc flash quenching, the quenching also, which will ensure the elimination of the short circuit within 4 milliseconds.
Mm.
Within 4 milliseconds, right? Quenching and detection both.
Mm.
So quenching has to be removed, making the circuit breaker comes into the picture and attend for the short circuit. That takes about 67 milliseconds minimum, right? If some products are being considered, that will take more than 110 milliseconds, even though this is called tripping from the instantaneous trip region. So if the arc flash is sustaining that long, the energy which is emitted, the as heat is going to be really high, making sure all these PVC, ABC, and all the other plastic based material catch fire. If those plastic based material catch fire, there's no way of suppressing it. It is very difficult, right? Even though you said this LSHF cable, it will catch fire. It's not a fire rated cable. What it does is it limits emission of halides, harmful gases. It limit emission of harmful gases, right? And it's limit spread. That's true. But all these vinyl boards, right, and other perspex material and all inside those distribution boards will catch fire, especially those consumer boxes. One other thing, even though these installations are tested, so we do thermographic surveys, and very easily I can reissue the same report in the next survey as well. We give the report, the same is still there in the next year. That's guaranteed, right? This pay us, take the report, but don't attend. So what to do? The operation, maintenance, design, selection, all should be in line to focus the safety and protection.
Right. Okay, Kuchana, I just want to bring you one not in the our from the audience. I have received the personal message to my WhatsApp. This question is direct to you. So I will just rewording this question. Now the question is the importance of SPD, the surge protection devices, to the system, electrical system, the LV system design. So give the brief answer about this, how the importance of usage of SBDs.
Yes, Engineer Suru, we know that because of the direct lightning that our in whatever the service cable that induce surges, then directly it comes to the our let's say main panel or from the telecommunication lines. So I think very basic description is that in order to filter whatever the surges, then we need a surge protection device in our main panel. But as far as surges are concerned, though we have surge protection in our main panel, we know that surge has main part and the tail part as well. Once we suppress the main part in our main panel, but tail part of the surge, that it can go to the sub panels through the electrical circuits. So the better way is that we may have, definitely we have surge protection system in our main panel. In addition to that, if we have surge protection system in our sub panels, that is the best way to, in order to capture the surges, suppress the surge. And also third level is our equipment point. Even maybe we have to analyze and see the cost is the main concern. But as far as surges are concerned, that not only to the main panel, if we have very sensitive equipment like data centers and hospitals, like very sensitive equipment that we have, then we have to have surge protection in the main panel and sub panels in order to suppress the surge current. Not only to the surge protection, that earthing system should be clearly, we have low earth resistance as per the standard, and surge grounding conduct also as per the standard. Otherwise, without having surge protector, we can't suppress the surge. That is a very short answer, Isro.
Yes, yes. I think that you have to short the answer. The time is running up. So actually, really interesting session that we are conducting. But time is very limited, so I'm compelled to bring this session in the last of the last questions. Before that, I just want to highlight you. Currently, 120 plus subscribers are done from the YouTube channel, as well as the I cannot count about the Facebook viewers of this online session. This is live. It is on air session, live broadcasting through the YouTube and the Facebook. So even though this is live, I think that anyone can view through the YouTube at any time this discussion. It is totally unedited versions. You can view at any time. Yes. With that, I have to come to the end of the session. So that's my final questions. It is open to the all distinguished panel members. So how do I end this one? Yes, I thought of having this question to open to the all. Now the Kaushalya, when he's come to the his CPD deliverables, he mentioned about the future of the LV system design. He has, but I know that he has a lots of things to cover, but he has done very justification for the course. That is how this course is more popular in the among the members. But he has bring these topics at the future of this LV system. Now we are hearing about the word about these DC microgrids and on-site solar and solar storage and the bidirectional EV chargers as well as the LED lightings. So maybe those would be the future as far as the technology is being updated. Those are the future. So from your expertise in Sri Lanka, the industry is the industry is ready to take up this new technology in our building. So are we in this level? Our demands and our other things like this now coming back now in Sri Lanka, the electrical EV vehicle is now becoming most popular in this, but it is very established in the other world, but now it is being accelerated in Sri Lanka. So are we in a right position? Our industry and our designs are in this ready to take up this new technology like the on-site solar and solar storage and DC microgrids like this. Are we in that position to take? And I'd like to take up this question as an end of this session. So you give your regards as well your remarks for this course as well. So I'd like to start it from Danushka. So how do you think about these challenges and this new technology involvement for our system design?
Yeah, it's a little bit challenging question also. So let me part by part answer it. Like one thing, we are getting flooded with EV vehicles, right? So rather than looking at a very long-term smart grid level, so we are seeing that especially the apartments and everything is not ready, not having the capacity or the ready to have this EV vehicle integration. So I can ask our design engineers. So when you are designing, especially the apartments, now this is the trend. Like EV, you can't stop; it will come. So keep the provisions for charging, slow charging as well as the fast charging. So that is a must, that you have to keep those provisions. That is very basic thing, right? So when it comes to the second thing, the smartness. So when it comes to the smartness, the world is already developed the standards and everything. If you go to if you see the ISO 1, if I remember correctly, ISO 15118 defines the standard for V2G charging stations. So if anybody interested, you can go and follow the standard there. It defines how the V2G charging stations should be communicated to the vehicle, and how the load balancing and the grid balancing, everything is happen. So on that standard, the communication, everything will happen. So if anybody interested, you can go and see that. So that we have to get ready also. Like some vehicles like BYDs already have that capacity. The V2G function is there. Some people, I know people are using to regenerate whenever there is a power shutdown or something. You can get the power from the vehicle. So that the next step is the synchronizing with the grid, the vehicle. So in let's say in the large capacity, when you have thousands of EV vehicles, so those batteries can be considered as a battery bank. So during the daytime or the unused time, that those capacities of the vehicle can be used as a demand management for the grid. So that those standards are there. So the in some countries those testing are been doing, not in the large scale. I would say those also are on the test levels. How these fluctuations and the grid management is happening, the communication, especially how the grid control center can send the messages to the vehicles to control those the charging or the discharging to the grid. So those things are still under on the, let's say, pilot sessions, but it will come like within a couple of years, other countries will use it, and Sri Lanka also will have to use those things because in future I can see that the EV will be a very major factor in our energy consumption. So those things also we'll have to look into in future when we considering the buildings also.
Yeah, Dhanushka, thank you. Kujana, so anything you can add?
Yes. Yes, Engineer Suru, that nowadays actually in our few projects also the demanding of the EV chargers for the apartment projects, ongoing apartment projects even now there is a trend to add this particular EV charging point for the car parks. And also the housing, let's say 2-story, 3-story houses, definitely client they need 1 or 2 EV charging bay in their that car parking space, that garage space. That is new trend, I think. For the apartment, earlier we did only slow charging point, that for the few, very, very, very few. But nowadays, the trend goes to other way, that every apartment they need sometimes 3 kilowatt, 6 kilowatt, sometimes maybe 11 kilowatt charges they requested. But then we have to see what happens for our transformer and generator capacity. Anyway, now that is the trend now we are facing. And other than that, G2 grid, I think the particular bidirectional charges or converters, that approval for that PUC approval and CB approval for the grid connection, that may be that is challenging task. That is because bidirectional charges with the IGBT inverters, as Dhanushka said, there are a lot of harmonics and everything, that compliance, we have to get the approval that anyway, that G2H, I think vehicle to home or vehicle to building like things, that is possible, no? Yes, there are now EV that compatibility was also there. I think that is emerging trend in future projects and future market.
Yeah,
So,
thank
yes.
you. I think the course was started by the voice of the Kaushalya, and so I would like to end this session from the voice of you, Kaushalya, because you are the key person here. So I think because you did a good job to delivering these the CPD courses, and so, and what is your advice for the designers, and so how do you apply the new technology to the design, and what is your final remarks for the courses and for the industry through this course?
Let's see how we are going to answer that. Yes, I think the engineers in Sri Lanka, they are very capable set of folks, right? So they are improving their knowledge, they are updating themselves, and they have the passion in doing this. So because of that, things are adding. So whatever the things invented, at least one or two is here visible and can be experienced here in Sri Lanka, even at small scale level. When it comes to IoT, those EV and all, it is there, right? The only thing is the frameworks, how to integrate all these into a system is pretty lacking. That's what happened with solar, emerging of the solar market as well. So for designers to have them in the designs, that's I think it's a very the gap is very small. The only thing is, if all this is incorporated in many designs, how the grid is going to respond is can be an issue. So today, during the weekends, it is announced to deactivate your solar systems because of issues with demand management. So solar was integrated without a proper forecasting and proper way of managing it. Likewise, the frameworks should be developed subsequently when these are emerging and these are going to be inbuilt into the system. I think we are lacking there, not that how to design things using these things. Especially Danushka discussed about harmonics and all. If the harmonic content is going to be increased, what is going to happen? And what are the frameworks available for those, right? And what are the standards to limit some cheaper products which generate harmonics and other impurities to your systems, right? What brings down power quality? So we don't have a proper framework on these. So everything can be implemented without an issue. The only thing is these frameworks and how the grid is going to react for all these. And apart from that, the uh, updates which is needed from individual ends. For existing buildings, I think a lot more changes are needed. And but for designs which is carrying out for newly proposed buildings, as Kujan and Danushka said, yes, those can be very easily be incorporated with. But we are not so far behind with the technology. So I think, yes, it's not a hype for us, all our engineering community.
Okay. So thank you, gentlemen. So actually, this is not right
Thank
time
you,
to stop.
Engineer Isuru. So I
Okay.
want to tell something about Engineer Kausalya.
Yeah.
At the beginning of this webinar, Engineer Kausalya explained anything and everything that we want to study. He explained from day one to today that so we are closing this webinar.
Okay.
He gave us a good knowledge about electrical installation and electrical protection and all the things. That is very beneficial for us and fruitful program. It is very nice one, and he tirelessly explained all the things starting from 6 o'clock to 9 o'clock without giving any break. But he gave his fullest knowledge to us. That is very nice because he tried to give more things to us. Then we also grab more. Thank you very much, Engineer Kaushalya. That's very nice. That's why I want to thanks to you, and as well as CEO Isuru, that you also, and Engineer Danushka and Engineer Pujana. So we today at the panel discussion we got more, and so if we can further to discuss this one, that is better. But the time constraint is the most getting so we ask. Then thank you very much for your program. So we will introduce other people also to connect with the next program and get more about electrical engineering side. Thank you very much.
Yeah, thank you. Thank you very much. Actually, on behalf of Building Services Industrial Campus, that's your regard is a more valuable things. That's what we are earning here. Because now this is purely established. We are about to celebrate the 2 years of this BSIC maybe next month. So this is purely established because of you, because of this industry. We know the industry requirement, and that is why we are again. And thank you very much once again, your regards and your appreciation. So this is cannot give any value. It is very very valuable. So we can't even give the unlimited. So I can say the word is that's the thing. Okay. Thank you. The three gentlemen, you are contributing your time. I know, because you know this importance of delivering such thing to the our industry. Actually, this is a live program. It's not any editors. There are some disturbances that is being happening in every programming, but that we can accept. But anyway, so we have come to the end of the another interactive and meaningful and important panel discussion being conducted by the BSIC through on air. So we will be more in future in such kind of panel discussion as well as CPDs. So for your information, the upcoming CPDs, like, so we are planning to have the swimming pool system design. This is the first time in Sri Lanka, especially for the swimming pool, CPD course is being conducted to the professionals. So it will be come to the early August, as well as they are planning to the building information modeling integrated solution for the architect, MEP and structural to the Revit 2026 version, as well as the structured cabling and IT network design courses also is being conducted, and also, as Kaushal mentioned, the power quality maintenance and things to be planning, and also the vertical transportation course also for the building is being planning. So you can entertain those courses in through the BSIC online platform in near future. So please be online and be connected with this our group. The BSIC networks is one of the largest professional network is being maintained in Sri Lanka through these professionals. So with that, I think I would like to invite
Isuru, if you can give me a minute.
Sure, Kaushalya.
Yes, and I, as the resource person during the lecture series, for selecting me, I would like to thank BSIC and Engineer Lakmal, and for all the participants, and Mr. Kujan as well, and for all the participants. It was a very hectic time period from 6 to 9. So being with me patiently, and for these 7 consecutive lectures. So thank you very much, all of you. And Danushka, Kujana, and Isuru, again, thank you very much for sharing your knowledge with the participants today, and sparing your time and dedicating your time for this event. Thank you very much. Thank you. Good night.
Right. Okay. I think I supposed to invite the BSIC administration team to have some official vote of thanks, but unfortunately, again has a connection issue from my program coordinator. So with that, I will end up with the formal vote of thanks. First of all, I must thank to distinguished panel members, Engineer Kaushalya, Engineer Koojana, and Engineer Dhanushka. So your commitment and dedication, especially for the times, your time, the value of time is we cannot, as a BSIC team, we cannot value your time, but so your generousness is more unvaluable for this kind of the forum, because we know that you are the bunch of knowledge and experience that we are sharing. That is why that kind of regards coming from the audience as well. So first of all, I must thanks Engineer Kaushalya, the senior lecturer of this course, and to our council members of the BSIC, Engineer Kuchan and Engineer Dhanushka, to accepting this panel discussion invitation and delivering with us. Then again, the participants from the Zoom throughout these courses for the 8 days with the Kaushalya, as well as in this panel discussion. And be patient, as Kaushalya mentioned, and be interactive with us. Your interaction is more valuable, and we keep keep ours is energetic mode. That's why. So I must thank for you for your engagement, as well as today this is broadcasted on air as a live stream through WhatsApp, Facebook and the YouTube channel under BSIC. I pretty sure there are 200 plus viewers there to the entire courses internationally, the worldwide. So thank you very much for be online with us for this courses, with this session at the end. And also my next thank goes to the our program coordinator, the Tassarani. She's the behind the scene and do the massive jobs entire from the starting to end, the coordination with the among the panel members and lecturers, especially students, and so I am really appreciate your noble commitment to the BSIC growth, and thank you very much, Sarani, for your effort behind the scene. And the BSIC Council and the management, to bring this platform that level to deliver this kind of knowledge sharing and the important courses session for the industry. With that, I would officially conclude the session. We will be back for this kind of session in the near future. Another panel discussion in this important course. With that, I will officially conclude the session, and thank you very much. Good night to all.
Thank you very much and good night.
Thank you. Good night. All.
Good night.
Thank you. Good night, sir.
Good night. See you again.